So part C is asking us to find the volume of a solid using square cross-sections that are perpendicular to the y-axis. Now in the picture labeled number 1, you can see a 3D representation of our two functions with the square cross-section. The red and the green lines are our two functions f of x and g of x. Now, since it says to use it perpendicular to the y-axis, we have to get our functions in terms of y. So f of x, which is radical x, will become y squared equals x. And g of x, which equals x over 3, becomes 3y equals x. Now we're also going to be using g of x minus f of x because we're doing it in terms of y. Now, just like in part B, to find the volume, we have to take the integral of the area. And in this case, the area will be of a square because that's what it tells us to use. So the area of a square is length times width, or height times height in our case. And h equals g of x minus f of x because that's the difference between our two functions, the red and the green line. The depth of the actual cube, which is what it shows in the picture, is dy, and that's just some very small number. So our integral will be 0 to 3 because we take the intersection point in terms of y, and then g of x minus f of x squared, which is 3y minus y squared, and all that squared, times dy. And if you plug that into your calculator, you get 8.1 square units.